Hey guys, welcome back to my channel. Today we are continuing our DSA series with two easy problems but super important array problems. So we'll solve remove duplicate from sorted array and merge two sorted arrays. So I'll explain everything step by step: intuition, dry run, brute force and optimal approach. So let's get started. So we are given a sorted array, example 1 1 2 3 3 4. So our task is to remove the duplicate in place, meaning we don't want to use another array if possible. So we want only unique elements at the start, so we'll return the length of that array. Since the array is sorted, duplicates will always be together. This is important for our approach. Think of lockers in a row. Each locker has a number. We only want one item per locker number and extras are ignored. So brute force is simple. Create a new array and add numbers only if they are different from the previous one. Works fine but uses extra space. So like there will be two arrays. One is the original one and another is the temp. So we'll check each element. If it's different from the previous one, so we'll copy it to the new array, temp. Finally, we'll copy back to the original array. So this time complexity will be big O of n and space complexity will be big O of n. Because we are using another array, so space complexity will be big O of n. So we need to improve this. So for the optimal approach, we'll use the 2 pointers. So there will be 2 pointers. One will be I and one will be J. So I will keep the track of the unique element and pointer J will scan the array. So when the nums of J is different from the nums of I, will increment I and write nums of J there. So this way all the unique elements are at the front. Okay, so no extra space is needed. So we'll see the dry run of this. Okay, this is the array. So first I will be at 0, 0th index. I will be at 0, J will be at 1. So nums of I is 0 and nums of J is also 0. Both are 0. So we'll compare them and it's returning false. So it's duplicate, so we'll skip it and we'll move J to the next element. So J will be moved here. So now I adds 0, J is at 2. So nums of J is 1 and nums of I is 0. So it's true. So we found the new unique element, right? So we'll increment now the I. So now I will be here and j is here. So I will be at 1. So we need to update the nums of I equals to j. Okay, so nums of 1 will be 1. So now array will be nums of 0 and 1. So we will get the first two unique elements. So now we need to move again j. So j will be at 3. J is at 3. And I is at here. So like both are 1 1, so we'll skip it. Again j will move forward. J will be at 4. Again we'll skip it. So now j will be at 2. So we have updated this, so it will be 1, right? So we got this. Now I is at 1 and j is at 2. So we need to update this. So 2 will be here. So now 0, 1 and 2 is the array. Then j will move forward until this. So now like array will be like we'll get the 5 unique elements at the front. So like this you can remove the duplicates using the 2 pointers. So time complexity is big O of n, space complexity is big O of 1. So we improve the space from big O of n to big O of 1. So this is clear and efficient. Okay, so next problem is merge two sorted arrays. So let's see. So we have two sorted arrays. So we have to merge these two as a one sorted array. So num1 has the extra space to hold nums2. Okay. So now brute force will copy nums2 into nums1, then sort the whole array. Brute force is basically easy, so we'll like it's just copy plus sort. So this is simple, but sorting will cost big O of m plus n log m plus n. So not optimal for large arrays. So we'll see the optimal approach. So since both i's are sorted, so we can merge from the AND to avoid the overwriting. So there will be 3 pointers: I, J and K. So basically I will be pointed at the last element in nums1. That will be valid element. So initially it will be m minus 1. Okay, so I will be pointed here and J will be pointed to the last element in nums2. So it will be 6. And there will be third pointer, that will be the K. So K points to the last element in nums1. That will be last index in nums1. That will be K here. That is m plus n minus 1. That is 3 plus 3 minus 1. 5 index. So K will be pointed at 5th index. So we have initialized the pointers. Now we'll compare. So we'll compare nums 1 of I, that is 3 to 6. So 6 is greater than 3 at nums 1k. So we'll place 6. We'll place 6 at nums 1 of k. So here will be 6. Then we'll decrement the pointers. So now j will be at 5. So now our array is 1, 2, 3, 0, 0 and 6. So now we'll compare nums 1 of I, that is 3 with 5. 5 is greater. So we'll decrement j and also we'll first place the 5 at the nums 1 of k, that is here. Okay. So now our array is 1, 2, 3, 0, 5, 6. So now we'll decrement the pointers. So j will come at 2. Okay. So now we'll compare it again. So we'll place. So we'll compare. So like 3 is greater than 2. So we'll place 3, that is this, at here. So here. So our array will be 1, 2, 3, 3, 5 and 6. So now next is I will be decremented here. So 2 and 2, right? So 2, they are both equal. So we'll place it at nums 1 of k. So we get our array will be 1, 2, 2, 3, 5, 6. Okay. So now if we decrement j, it will go j equals to -1, which is not right. So we'll check like nums 1 elements, that the remaining elements are at the place, right? Are already at the place. So this will be the final array. So time complexity will be big O of n plus n and space complexity big O of 1. So let's recap what we did. So we first solved the remove duplicates, used 2 pointers to keep only unique elements. Then we done the merge to sorted, which we merged from the end using 2 pointers. So arrays are the foundation for many DSA problems. 2 pointers and variants help visualize and solve problems efficiently. So if you found this helpful, hit like, subscribe and comment the next problem you want me to solve. So stay consistent, keep practicing, and I'll see you in the next video.